Tesla Battery Day, as it happened, was a trip into Tesla engineering thinking. Hello guys, and welcome back to the channel. If you are new to the channel, please do consider subscribing. And now let's get back to the details about Tesla Battery Day. So the long wait has come to an end as the Tesla Battery Day is over. We got some of the expected news with more details and articulated ambitions and a promise of a 25K Tesla car. The Tesla Battery Day had been on the agenda since spring when it first got delayed with no reason and then due to the encroaching pandemic. When it finally happened, it was on the back of the company's annual shareholder meeting. The wait definitely increased the suspense. During the event, Tesla has confirmed in-house battery cell production. The new cells, designated 4860, are claimed to be bigger and better, not the least because of advances in production. The key will be the use of a dry electrode in addition to a tabless design. The cells will also integrate into the vehicle as an entirely structural component. The overall goal is a range increase of up to 54% and simultaneous reductions in kilowatt-hour price by 56% and the investment per gigawatt-hour by 69%. This reduction in battery price would also make the mentioned promise of Elon Musk of a $25,000 electric vehicle possible. He reckoned 3 years from now if the advances presented on Battery Day materialize in time. Also impressive is the long-term plan of a total Tesla battery output of 100 gigawatt-hour by 2022 and 3 terawatt-hour by 2030. That's supplemental to what Tesla buy from their usual suppliers. Elon Musk has said as much ahead of the big day. On Twitter, he had assured the expectant crowd 24 hours ago that nothing would happen just yet. He said, "We intend to increase, not reduce, battery cell purchases from Panasonic, LG, and Cathodes, possibly other partners too. However, even with our cell suppliers going at maximum speed, we still foresee significant shortages in 2022 and beyond unless we also take action ourselves." So indeed, Battery Day brought set action plan. Tesla has thrown ambitious targets behind previous guesses as usual, this time followed up by serious engineering details and possible advances in manufacturing. Still, the new cells are the biggest news, with Tesla introducing a new 4680 cell format. The numbers designate the size of the cylindrical cells. These offer 6 times the power of Tesla's previous cells and 5 times the energy capacity. This could result in a range increase of around 16% through cell design alone. The new design also does away with the tab that connects the cell and what it's powering. Tesla claimed that tabless cells would accelerate the production process, with the pace being on their agenda since the days of Panasonic delays. Production and efficiency increases was a recurring theme in the presentation, but the guiding topic was cost reduction on every level. Tesla said they would halve the cost per kilowatt hour as they had looked to improve cell design, cell manufacturing, anode materials, cathode materials, and vehicle integration, each elemental to the envisioned increase in range of up to 54% and simultaneous reductions in kilowatt-hour price by 56% and the investment per gigawatt-hour by 69% as mentioned previously. The last target shows that Tesla now explicitly thinks in terawatt hours when thinking of Tesla battery production in-house in the long term. We know that the so-called Terra expansion at Tesla's Fremont facility had been in swing since summer. Now it's clear that the site is host to the new 4680 cell production, a likely cathode production, and the company stressed they were ramping up manufacturing of these cells at Terra factory already on the pilot production line. Musk promised it will take about a year to reach the 10 gigawatt hour capacity at the pilot plant. The actual production plants will be more like 200 gigawatt hour over time, he added. Still, Musk added caution when it comes to actual production, as the trick is the machine, said Musk. Making the machine that makes the machine is vastly harder than the machine itself. He would repeat this statement during the shareholder meeting multiple times. The truth of it appeared in the machines helping to make the new electrode for the 4680 cells. The cost reduction is in large parts to come through the previously announced dry electrode technology. It does away with the wet solvent during production and applies the power directly into the film, as Tesla explained. That's in theory. Musk admitted they had still a lot of work to do on the machine they acquired from Maxwell and have revised 4 times since. Right now it's close to working but not with a good yield, added the Tesla boss. He thinks the machine finally enabling large-scale production will be revisions number 6 or 7. That's about 3 years to reach the benefits and 1 year to scale up fully, Musk concluded. Safer footing appeared in the form of the die-cast machines for the Model Y. The so-called Giga presses, also planned for Giga Berlin, allow casting the Model Y body in only 2 parts and from a new alloy that does not need heat treating or coating when cast. This new body now also allows for a new battery vehicle integration, so the battery becomes dual use as an energy resource and structural component. Musk explained that the new cell packing directly inside the frame nearly loses the packaging that is not structural to the vehicle. This then allows Tesla to pack more cells and to move them closer to the center of the car. Apart from the making, there is the makeup and chemistry of parts like the anode first. The company relies on silicon only. Musk compared the current issues with silicon anodes with a cookie that crumbles and gets gooey. The company claims, however, to have gone back to the raw ingredients, now mixing the raw silicon without engineering a base metal to then stabilize the surface with a polymer coating and integrate it with a highly elastic binder. The exact composition remained unclear at this stage. On the cathode level, the image was of a bookshelf stable enough to keep the books or ions moving on and off. Tesla plans to use the cheaper nickel primarily and get rid of cobalt in the long run. The latter is a move many car makers, including Tesla, have been striving for. At the same time, Musk put expectations into perspective, also adding that they don't want to be constrained by nickel availability. Instead, there is a 3-tier approach with high nickel cells for the semi and Cybertruck, with a 2/3 nickel and 1/3 manganese mix intermediate solutions, that's cars, and the iron mix for stationary energy solutions. And this is not too far from Tesla's supplier reality. Panasonic, for example, combines nickel and cobalt in the current cells. Then some Chinese Model 3 features lithium iron phosphate cells from Cathodes, though cobalt-free as reported. Tesla also continues to use NCM 800 cells for the long-range Model 3 in China. The batteries supplied by LG Chem comprise 80% nickel and 10% each cobalt and manganese. In any case, the search for nickel had intensified in recent weeks, with rumors also suggesting Musk was speaking to Canada's Giga Metal. This approach to localizing the supply chain again reappeared in the presentation. Tesla claims to have secured a lithium reserve in Nevada that spans 10,000 acres. The company expected to hold enough resource on a terawatt-hour scale and said it could extract the lithium from the ore using salt and putting the earth back. Tesla also has a long-term bet on recycling. The company said they expect recovery rates of 20%, 2.7%, and 2% for nickel, lithium, and cobalt from batteries deployed in its vehicle fleets. Tesla took the opportunity also to unveil the Model S Plaid. The triple motor car goes 520 plus miles at 200 miles per hour and 0 to 60 miles per hour in less than 2 seconds. That was after Elon Musk had stressed it's absolutely critical that we make cars that people can actually afford. He added, affordability is key to how we scale.